This is it, guys. You've made it. This is the last lesson in Math 10-3, Chapter 7, 7.5. It's called Finding Angles. Before we do that, let's do a quick bit of review on the first three trig ratios because it's really important to be able to set everything up and discern which ratio we want to use. Okay, take a look at this question. And all these instructions are pretty important. They're what you want to do for each question. Part 2, you only need to do one of them, but in this one, we're going to do all three. So copy and label the diagram. From the perspective of angle A, label the hypotenuse. So this is my angle A. Label the hypotenuse. Hypotenuse doesn't care if it's angle A or angle B. It's always across from the right angle. So that one's easy. That's my hypotenuse. The opposite side from angle A is going to be here. If we were doing angle B, of course, it'd be down here, right? So from angle A, this is my opposite side, and this is my adjacent side. It's always going to be one of your first steps, drawing the diagram, labeling your opposite adjacent hypotenuse. Write the formulas for the three trig ratios you've learned. So, ka, toa. You've learned it, right? So, ka, toa. Sine equals opposite over hypotenuse. That's what the OH stands for. Cosine equals adjacent over hypotenuse. That's what the AH stands for. And tangent is opposite over adjacent, OA. All right, now using one of the trig ratios, they're not necessarily yours, they're all of ours. Calculate the length of side B to 1 decimal. We're asked for side B again, and we don't have any sides labeled side B. What do? We label side B. Where do we find side B? We find side B across from angle B. So this is side B. This is side A. This is side C. Because the lowercase side names are always across from the uppercase angle names. Right? Same letter for the side that's across from the angle, just lowercase. All right, so now side B, that's this one, the adjacent. And we're given the hypotenuse. If we're looking for the adjacent and we're given the hypotenuse, sure, we could figure out our sine first and then use the tangent ratio to, why would we do that? Let's just jump straight to the one that has adjacent and hypotenuse in it, which is cosine. We're going to use cosine theta equals adjacent over hypotenuse. So cosine of my angle 32 equals adjacent, which is B, unknown, over my hypotenuse 8.4, in this case centimeters. When my variable's on top, I multiply by the trig ratio. When my variable's on the bottom, I divide by the trig ratio. In this case, it's on top. So B is going to be equal to 8.4 centimeters times the trig ratio, cosine of 32. Pull up my calculator. They're pretty necessary for this unit. You actually can't do anything without them. 8.4 times the cosine of 32, and I figure out with this calculator, I have to plug in 32 first, and then get the cosine, because that's going to do cosine of 32 for me. I figured that out the first time I tried to use this calculator, because I did 8.4 first, and then times cosine, and it did the cosine of 8.4. Just pay attention as your calculator's doing it. If it immediately changes the number when you hit your trig ratio, then you know that it's not waiting for you to put the number in brackets, it's taking the number you just put in and doing the trig ratio to it. And you always have to press equals, and so we got 7.123, or 7.1 centimeters. Does that make sense here? This is going to be the long leg of my triangle. It's smaller than my hypotenuse though. Yeah, it's a good answer. Okay, so today's lesson is about finding angles and solving right triangles. So far, we solved for missing side lengths. We used our three ratios SOHCAHTOA, but we can also use them backwards to solve for missing angles. So in order to do this, though, we need to use sort of an inverse operation. So if I'm going to try to solve what am I writing? Cosine of theta equals adjacent over hypotenuse. Right? And if I want to solve for this theta, I got to somehow get rid of this cosine. Well, when we were getting rid of something in the denominator, we had to multiply both sides by that denominator. When we're getting rid of like a +3, then we got to subtract 3 to get rid of it. How are we going to get rid of that cosine? It's not multiplying by theta. It's a function that's applied to that theta. We got to do the opposite operation. And really, the only way to do the opposite operation is by defining a new operation called the inverse cosine. And it looks like this. Cosine inverse. Cosine to the -1. So we're going to take the cosine inverse of both sides of this equation. Because the cosine inverse is the function that is designed to get rid of cosine and leave theta by itself. So when we do this, it does its job. They cancel each other out. We're left with just theta equals the inverse cosine of adjacent over hypotenuse. So as we looked at the other day, when we were solving for side lengths, if our variable was in the top, we multiplied by the trig function. If our variable was in the bottom, we divided by the trig function. Now our variable's over in the trig function. We don't have a variable on the top or bottom of our ratio. We've got to use the inverse trig function. So top multiply, bottom divide. On the other side, take the inverse. When we're looking for the angle, when we're trying to solve for the angle, we take the inverse trig function. Okay, very important to remember. All right, and I'll show you where to find it on a lot of calculators. It's usually a second function of the normal function. So calculate each angle to the nearest degree. If we know that the ratio of two sides in a triangle, if the opposite of the hypotenuse is 0.2546, we can figure out what that angle is. Let's move that down just a little bit. Okay, so 0.2546, and I want to use trig. In this case, look at that. I don't have inverse, do I? Do the second function. Now, look at that. Now I've got all these inverses showing up. So the sine inverse of 0.2546 equals, oh no, let's see now. Here you don't want to hit equals, because now I did that sine inverse times that. I want to go back a step. Oh, no, get that. Oh, I just killed my history. Give me back my calculator. I just 0.2546 trig second sine inverse. And this tells me sine inverse of 0.2546. Okay, and that's 14.8 degrees. Cosine inverse of 0.1598. Wish sometimes that I had this menu bar. Cosine inverse of 0.1598. That trig second function, I want the close inverse of that. 80.80. 80.8 degrees. And finally, the inverse tangent of 3.2785. 3.2785. Oh, I did it again. Yeah, I don't want to hit equals because then it multiplies it by that other number. I don't want to delete that. Oh, and I closed my calculator completely. Good job, me. Here we go. 3.2785. Trig, second, tan inverse is 73.03 degrees. 73.03, that's 73.0. Okay, so to find the angle, we use the inverse function of that ratio. So of 0.2546, of 0.1598, of 3.2785. And for the most part, when we're looking at angles, we're looking at things like this, between 10 and 90 degrees, somewhere in there. When we're looking at the actual ratio, notice that sine A and cos B are both between 0 and 1. They're always between 0 and 1, right? Because when you divide two sides of a triangle, the hypotenuse is always the biggest. So you're dividing by something bigger than itself, it's got to be less than 1. When we get to tangent, that's when we can have one side that's a lot longer than the other. All right, let's take a look at some actual problems here. Calculate the angle. Oh, the angle to the nearest degree. Sine of D is equal to 0.5491. So to solve for that, we're going to do the opposite operation of D, which is sine inverse of 0.5491. And 0.5491 trig. Second function, sine inverse, 33.3 degrees. That's nearest degree though, so I just do 33 degrees. If we have right triangle XYZ, the ratio of the side opposite angle X to the hypotenuse is 7/8. What is the approximate size of angle X? Yeah, some people are going to be tempted to jump right into this. There's like an 80% chance you're going to get the wrong answer if you don't draw a diagram first. Draw the diagram, it's easy. We're always doing right triangles. Here's a right triangle. XYZ, ratio of the side opposite angle X to the hypotenuse is 7 to 8. 8, let's call that 7, so this is X, Y, Z. What is the approximate size of angle X? Well, this is the hypotenuse. This is the opposite. So, uses opposite and hypotenuse. So we're going to say sine of my angle X equals opposite over hypotenuse. I'm sorry, sine theta equals opposite over hypotenuse. Let's put in our real numbers. We have a number for the opposite, but we don't have a number for the angle yet, right? That's unknown. Opposite is 7, hypotenuse is 8. See here, we don't have a variable in the top or the bottom. We have it over here, trapped inside this sine. We free it from that sine function by doing the opposite operation, which is the sine inverse. So theta or X equals sine inverse of 7/8. Sorry, hopefully you can see that still. A little bit. Sine inverse of 7 over 8. Seven divided by 8. Now here I'm going to have to do 7 divided by 8 equals, to get this number showing on my screen, then trig, second sine inverse. So it did sine inverse of the answer to 7 over 8, 0.875. Okay, and the answer is 61.0 degrees. 61 degrees. 61 degrees in there, which makes sense, right? This is almost as big as that, so this is probably a large angle. Indeed it is. Okay. At what angle to the ground must you place a support if it is 6.8 meters long and must reach 4.2 meters up the side of a tower? Remember what unit we're doing. This is confusing if you don't remember, hey, we're doing right angled triangles. Let's draw this. Let's draw a tower. This is my tower. I don't know why it looks like that. Let's make it more like the Calgary Tower. Actually, let's just make it a vertical line. There, that's my tower. And I've got a support placed at an angle reaches 4.2 meters up the side of the tower. It's 6.8 meters long. This is the ground. The tower is straight up and down. Hey, there's a right angle triangle. At what angle to the ground? So what's this angle here? Is the question. Okay, now we know what angle we're looking for. We label these. This is opposite. This is hypotenuse. All right, I got opposite and hypotenuse. Which trig function do I use? So opposite and hypotenuse. So sine of my angle equals opposite over hypotenuse. Always the first step, write down that trig ratio. Then put the numbers in that you know. We don't know what theta is, so we're going to do sine theta equals opposite, which is 4.2 over 6.8. And so if I know that sine theta equals 4.2 over 6.8, to get rid of this sign and get theta by itself, I do the opposite operation. So theta equals sine inverse of 4.2 over 6.8. Grab my calculator again. 4.2 divided by 6.8 equals, that's my ratio of the two sides. Take the inverse sine of it, and I get an angle of 38.1 degrees. 38.1 degrees. I'll buy that for $1. Seems to be a reasonable estimate. Right, it's between 10 and 90. For these, for the most part, if you did the opposite, if you did 6.8 over 4.2, I believe your calculator will give you an error because you would then have a number larger than 1. Let's try it. Just try it on your own as well, because you'll want to know if your calculator will throw that error at you. 6.8 divided by 4.2 equals trig sine inverse. Invalid input. Okay, what if I forget to put the equals? 4.2 divided by 6.8, and I go straight into sine inverse. Invalid input, because what did it try to do? It tried to divide 4.2 by sine of a number bigger than 1. You can't do that. So a lot of things that might be typical mistakes, you're going to get an error message. If you get an error message, usually means you made a mistake. Either you divided your hypotenuse by one of your legs, or you've tried to calculate too soon. You haven't actually solved that ratio first. See what else we have. I can't remember how many more slides we got. All the way up to 10 we are. Okay. So this one's a little longer, but gets the last of the practice. So solving a triangle, what does that mean? Solving a triangle means you find the values of all the sides, all the angles. With a right angle triangle, okay, we've already got one of them. So there's only two other angles. If we find one of them through trig, we can figure the third one out just by subtracting it from 90, because they all add up to 180. So two other angles add up to 90. Then there's three sides. If you have any two sides, then like O and H, or A and H, or O and A, and there's a trig ratio that'll let us find the angle. And there's the Pythagorean theorem that'll let us find the other side, right? So we can find all of those fairly easily. Or if you have one side and one angle, you can use your trig ratio to find the other values. So all you need is two sides or one side and one angle. You can figure everything else out. Okay, solve the given triangle without using the Pythagorean theorem. Without, okay, well, let's not use the Pythagorean theorem then. I have an angle here. So this is my opposite. I trace across the triangle to find that. This is my hypotenuse, and this is my adjacent. If this is 48 degrees and this is 90 degrees, then this has to be what plus 48 gives me 90 degrees. So this is 90, these two have to add up to 90. 42 degrees. Q is 42 degrees. That's part of solving. We've got all our angles. But let's just use this angle here. Opposite and hypotenuse, that's going to be sine 48 equals opposite. No, I'm skipping steps, and I shouldn't, because it's actually harder for me. I gotta think harder. Now, sine 48 equals the opposite is 5.4. Hypotenuse is r. So, variables in the bottom. What do? I divide by my trig ratio. R equals 5.4 divided by sine 48. And I'm actually going to hold off. I'm going to set up the next one as well. And then here, opposite and adjacent. That's tan theta. Tangent of 48 equals opposite, which is 5.4, over adjacent, which is Q. So I have Q 5.4 over tangent 48, right? Variables in the bottom, so I divide by my trig ratio. Okay, and this will allow me to solve for Q and R. Calculator again. Oh, I closed it again. All right. 5.4 divided by sine 48. Oh. Watch out when you're putting things in. 5.4, not 55.4, divided by 48. Hopefully your calculator does tell you what it's doing. So 5.4 divided by the sine of 48. And notice this is a very small number. That's your trig ratio only. I need to put equals. It's a 7.26. 7.26. And then 5.4 divided by tan 48. 5.4 divided by the tangent here. And the tangent of 48 is 1.11, but 5.4 divided by it is 4.86. Okay, what units do I need? Meters. Let's put those numbers in. Q is 4.86. And R is 7.26. I've got a full right triangle here. My hypotenuse should be the largest number. It is. My angles should all add up to 180, or my two acute angles need to add up to 90. They do. These two sides must be shorter than this side. When you add them, no, sorry. When you add these together, they have to be bigger than this side, and they are. This has got to be the biggest, but these two added together have to be bigger than that. Okay, so this is a fully solved triangle. I've got R, I've got Q, I've got my angles. So I've got 3 sides, 3 angles. Don't forget this one's a 90. Fully solved. All right, real skills, real jobs. 16-foot ladder is placed against a wall. Ladder reaches 12 feet up the wall. What angles did the ladder make with the ground round to the nearest 10th? Try. Pause and try. Okay. Now you've unpaused. Let's draw a diagram. We've got a ladder. We've got a wall. The ladder's leaning against the wall. It's 16 feet long. Remember, 1 tick mark is a foot. 2 tick marks is an inch, so just 1. The ladder reaches 12 feet up the wall. The ground makes the right angle with the wall. What angle does the ladder make with the ground? This is the angle I'm trying to solve for. Okay, so now I look at my triangle, I label hypotenuse, always across from the right angle. Go across the triangle from the angle I'm interested in, my reference angle. That's my opposite side. I've got opposite and hypotenuse. Trig ratio that uses opposite and hypotenuse is SOHCAHTOA, is sine. So sine of my angle equals opposite over hypotenuse. Sine of my angle is unknown. Opposite is 12. Hypotenuse is 16. So my angle, remember when I'm trying to find the angle, I use the inverse trig function. Don't do anything else with these. I just put them in the brackets. 12 over 16. And so I can solve this. 12 divided by 16. I want to put that whole thing into the sine function. So I get 0.75. Then I have trig. Second function, sine inverse of 0.75. 48.59 degrees. 49 degrees. 49 degrees. Yeah. If this is drawn mostly to scale, it's about 49 degrees. Okay, I believe this brings us to the last sample problem for math 10-3. Kind of sad, kind of happy that we're done, but I'm kind of happy that this whole COVID thing's drawing to a close, hopefully. If you're watching this at a later time, because I've left them attached, COVID was a crazy thing that happened in 2020, and basically the world shut down. Look it up. It happened. Very similar question. Ladders placed against a wall make an angle of 28 degrees with the ground. There's a lot of ladder questions. There's a lot of support wire questions. These are things in life that actually use trig. Also measuring distances across streams and heights of buildings. All those use trig. Surveyors use trig all the time. Just based on what they have, what they can measure easily. It's really hard to measure the distance across a pond because you can't walk across it. So you measure 2 distances that are not across the pond, and then you can kind of figure out the angle in between using trig. Ladder is placed against a wall, making an angle of 28 degrees with wall. Wall, let's put the ladder on this side for a change. I almost always do it the other way. Doesn't matter. Wall and the ground, make a 90-degree angle. Here we have an angle of 28 degrees with the wall. Be careful to read these questions. Where does that angle go? The ladder and the wall make an angle of 28 degrees. That's up here, ladder, wall, 28 degrees. If the ladder reaches 7 meters up the wall, how long is the ladder? I want to know how long the ladder is. Okay, so what do we got? We've got, if we go across, this is my opposite. This is my hypotenuse. And this is my adjacent. I have the adjacent. I want to solve for the hypotenuse. The adjacent. I want to solve for the hypotenuse. Which trig function do I choose? So, no, that doesn't have adjacent. Adjacent and hypotenuse, yes. So I'm going to use cosine of my angle equals adjacent over hypotenuse. Remember, write out that trig ratio. I can't believe how much more I had to think. Like there were a couple times in these videos where I tried to skip this step, and literally the thoughts in my head were so much more complex. It was so much harder to do the question. And I do this for a living. So don't skip this step. You're just learning it. You're just a student of this. So cosine of my angle is 28 degrees. Cosine 28 equals my adjacent 7 meters over hypotenuse. That's x that I'm trying to solve for. Boom. I've got it written out. I have one unknown. My unknown is in the bottom, which means I'm going to divide by the trig ratio. Cos 28. Oh, I'm going to divide by cos 28. So x equals 7 meters divided by cosine 28. Am I using the inverse trig function here? No, I'm not finding an angle. You only use the inverse one when you're trying to find the angle. I'm already given the angle. I just need to find this side length. So for the last time, I'm going to pull up my calculator here. I'm going to do 7 meters divided by the cosine of 28, which is 0.8829. And I get an answer of 7.9 meters. That's how long this ladder is supposed to be. Does that make sense? Is it bigger than 7 meters? Yes, it's the biggest number I have in this triangle. If this is a 28 degrees, then this side is going to be almost as big as this side, but not quite. So yeah, numbers make sense. This is a good answer. 7.9 meters is the length of the ladder. And we're done. I hope to see you next year, live and in person. It's been a pleasure teaching you.